Hello friends, in my earlier video I have already explained data transfer group of instructions from instruction set of 8051 and arithmetic instructions from instruction set of 8051. Today we are going to learn logical instructions from the instruction set of 8051. So there are in total 10 types of instructions in logical instruction group. We will see one by one all the instructions from logical instruction group. So the first one is ANL, destination byte comma source byte. So ANL is nothing but logical AND operation for byte variable. So this instruction performs bitwise logical AND operation between the destination and the source byte, and the result is stored in the destination byte. I will take one example of it. Example is ANL A comma RN. This is the one of the combination. There are 3 to 4 combinations can be written for the same instruction. So I'm taking only first combination, that is ANL A comma R5. What this particular instruction will do, this instruction will perform bitwise logical AND operation between the contents of the accumulator and the register Rn of the selected register bank, and the result is stored in the accumulator itself. So I'll consider this example. Say suppose this accumulator register is holding value FFH and R5 is holding value 15H. So the instruction ANL A comma R5 will logically AND the contents of accumulator, that is FFH, with the contents of register 5, that is nothing but 15H. The result of ANDing is stored in the accumulator and the result is 15H. So this was nothing but logical AND for byte variable. We will see the next instruction from the same group, that is nothing but ORL, destination comma source. So this is logical OR for byte variable. This instruction will bitwise or logically OR the contents of source and destination, and the results are again stored in destination. There are again 5 to 6 combinations for the same kind of instruction. I will take only first combination, that is ORL A comma RN. An example of it is ORL A comma R5. What this particular instruction will do, this instruction will perform bitwise logical OR operation between the contents of the accumulator and the register Rn of the selected register bank. The result will be stored in accumulator. Let A, say suppose accumulator is holding the value FFH and R5 is holding the value 15H, then the operation OR will give you result as FFH, and that FFH is stored in accumulator. Now we will see the third instruction, that is XRL, destination byte comma source byte. What XRL is? Logical exclusive OR of byte variables. So this will do what? This will perform XOR operation between destination and source, and the result is again stored in the destination. We will take example of it. XRL A comma RN, that is it will perform the operation of XOR between the contents of accumulator and between the contents of Rn of the selected register bank. I have taken example of it as XRL A comma R5. Say suppose A is having value FFH, accumulator is holding value FFH, and R5 is holding value 15H. So the logical XOR operation of these two contents is having result as EAH. So the accumulator will hold after the execution of this instruction value EAH, that is XOR of FFH and 15H. We will see the next type of instruction from the same group, that is nothing but CLRA. So CLR is nothing but clear accumulator. This will clear contents of the accumulator and this will set the contents to 0. So after clearing the bits, all bits of accumulator, the contents will become 0. So we'll take example of it, that is CLRA. Now say suppose initially A is having value 77H, and after execution of CLR A will have the value 00H. So which was initially 77H, after the execution it will become 00H. We will see the next instruction, that is RLA. So what sorry for the interruption. The next instruction is CLR is done, RLA. What RLA will do? This is nothing but rotate accumulator left. this will rotate 8 bits in the accumulator by 1 bit position to the left. So if bit 7 is there, bit 7 is rotated into bit 0. So bit 7 is rotated into 0 because you are rotating it to the left. We will take example of it. Rotate left accumulator. Suppose A is having value A, that is having value 45H. So 4 is written as 0100 and 5 is written as 0101. So if rotate left operation is performed, what will happen? It will be rotated to left by 1 position. Means whatever bit is there at D0 position will be rotated to the earlier bit, that is nothing but D1. D1 will be rotated to D2, D2 to D3, D3 to D4, like that. So how this will go? This 1C, this it was initially 1, so that 1 is shifted here. This was initially 1, this 0 is shifted here, then this 1 is shifted here, 0 again shifted here. So this is like rotating all the bits starting from this to 1. So whatever bit was there in D0, now it is shifted to D1, like that. So it is 8 bit number. So 8 bit numbers or 8 bits in the accumulator are rotated by 1 bit to the left. So whatever value was there at D7 will be now rotated to D0. Here in my case at D7 I was having 0, that D7 was rotated to bit 0. So this 0 will become here and all will be shifted to left. Next operation is RLCA. Now RLCA is nothing but rotate accumulator left through carry. Now what this will do? This will rotate 8 bits in the accumulator and the carry flag together by 1 bit to the left. We will take example of it so that you'll understand. Example is RLCA. So suppose A is having value 72H and carry flag is having value 1. So what I will do, I will write the carry flag over here, and 7 means 0111 and 2 means 0010. Now RLCA will do what? It will rotate accumulator left through carry. It means whatever was there in the carry will be rotated to the left and will be written as D0. So this 1 will go here. So you can see at the result 1 is here now, and all the bits will be shifted to the left by 1. So you can see here everything is shifted to the left by 1. So this will become this 1 here, then this 1 here. So this will become 111, 0, 0, 1, 0, and lastly the carry flag bit will be here at D0, that is 1. So the result is 11100101. Next instruction is RRA. This is nothing but rotate accumulator to the right. This will rotate the 8 bits in the accumulator by 1 position to the right. So bit 0 is rotated into bit 7 position. We'll take the example again. A is equal to 75H, and you can write the 7 as 0111 and 5 as 0101. But this is rotate to right. So if you are rotating it to right, bit 0 is rotated into 7th position. So you are rotating it to right. So you can see that D1 will become now your D0, D2 will become D1, D3 will become D2. So like that you will get the value as 0, 1, 0, 1, 1, 1, 0, and lastly 1. It means D0 will become D7. You can see D0 here was 1. It will become now D7. Next instruction will go to RRC, that is rotate accumulator right through carry. This will rotate 8 bits in the accumulator and carry flag together by 1 position to the right. This is contradictory to RLC. We'll take example of it. A is 85H and CY is equal to 1. So I have written the carry flag like this here, 1, 8 as 1000 and 5 as 0101. Now here in this case you'll have to rotate all the bits to the right. So if you're rotating all the bits to the right, your D0 here in this case, this is your carry flag bit. This is your D0. Your D0 will become carry flag bit. So your answer will be 1100 because you are shifting everything to right. So it will become 0. You can see here 0, then 1, 0, 0, 0, 0, 1 and 1. So your carry flag D0 bit will become carry flag. Your D0 will go here. Now your next instruction is swap A. This is swap nibbles within the accumulator. This is very simple. The instruction interchanges the lower order bit with the higher order nibbles of the accumulator. So the nibbles are swapped, lower order nibbles and higher order nibbles. We'll take example of it. Swap A. Consider A is equal to 87H. So 8 is written as 1000, whereas 7 is written as 0111. So after swapping bits, so these are higher order nibbles and these are lower order nibbles. So those lower order nibbles will go here and higher order nibbles will go here. So instead of 87H, it will become 78H. So it becomes 0111 and this becomes 1000 like that. Thank you.